Hello, algebra students. Today we are going to keep graphing our quadratic equations, which gives us a parabola as a shape. And we're going to be solving those equations now using graphing. We've already talked about finding the roots or finding the solutions or the zeros of the equation. It's where it crosses the x-axis. And that's what we're going to be doing today with these graphs. So as you can see, our standard form when we're graphing looks like this. If we're trying to solve this as an equation, the reason we say we're finding the zeros is that we're going to change the y into a zero when we're doing this. When we're graphing, honestly, that doesn't matter at all. What I want to be able to do is graph that equation, which will be a parabola, find where it crosses the x-axis, and on the x-axis, that's where the y is equal to 0. That's why we would substitute the 0 in there. Most of the time, we have two solutions. Our parabola will hit the x-axis in two different places. Occasionally, the vertex will be right on the x-axis, so we only get one solution. Sometimes our graph doesn't touch the x-axis at all, so we won't have any solutions. This is what it looks like. When we have a graph like the first one, I would get a solution here and a solution here. When the vertex is on the x-axis, that's where I get one solution. And again, remember, the solutions are where it crosses the x-axis. If this graph doesn't touch the x-axis, there are no solutions in terms of making the y equal to 0. So we have done quite a bit of graphing now. We are going to find our vertex, make a table of values, get the graph, and then from the graph, we want to find the zeros, find where it crosses the x-axis, and we can check those then with substitution if you'd like. So the first thing I need to do, I'm going to start with a is -2, b is 8, c is -6. The axis of symmetry, the opposite, let me just write it down the first time, the opposite of b over 2a. So I would have the opposite of 8, which would be -8, and 2 times the -2. So I have -8 over -4, which gives me 2. That's my axis of symmetry. It'll be right here at x equals 2. My vertex will be on that line. Now that I know what the x part of my vertex is, I can substitute that in to find the y part of my vertex. So I would get that y equals -2 times 2 squared plus 8 times 2 minus 6. At this point, if you feel really comfortable just doing this in your calculator, go ahead. Just be very careful. Make sure that you're getting your parentheses. Without a calculator, I can still do this because I'm just going to follow order of operations. 2 squared is 4 times -2 is going to be -8. 8 times 2 is 16. Right now, what I have just with those two would be 8. 8 minus 6 is 2. So my vertex is going to be at 2, 2. Right there. When I make my table of values, so 2, 2 is going to be my vertex that's in the center. So I would have smaller numbers for x and bigger numbers. And now I just substitute in. And again, 0 is my favorite thing to substitute. When I put a 0 in there, and I'll show you I'll write this out on this problem, but I don't think that I need to do it on all of the problems. I would have -2 times 0 squared. Well, 0 squared is 0, times -2 is still 0. 0 plus 8 times 0, well, that's another 0, minus 6. So 0, -6, right there. When I substitute in the 1, again, in your calculator, you would just change all those zeros into 1s then. So -2 times 1 squared, 1 squared is 1, times -2 is -2. 8 times 1 is 8. So -2 plus 8 is 6. And then 6 minus 6 is 0. So 1, 0. Again, once we know those, you should know what I should get for my y values for the 3 and the 4, but I'm still going to run the numbers through. So I would have negative 2 times 3 squared. 3 squared is 9 times the negative 2 is negative 18. 8 times 3 is 24. So negative 18 plus 24 is 6. Minus 6 is going to give me 0. And then negative 2 times 4 squared. 4 squared is 16 times negative 2 is negative 32. 8 times 4 is positive 32. That gives me 0. Minus 6 is negative 6. So here's my graph. Oh, I missed a little bit. And remember what I'm really looking for here is where it crosses the x-axis. It crosses right here at 1 and at 3. So 1 and 3 would be my answers. When I check this, if you wanted to check by substitution, well, I guess I don't even really need to show that work because I already found it right here, right? When the y is 0, the x is 1. And when the y is 0, the x is 3. Okay, in this problem, I don't even see all of my A, B, and C. All that I can see right now is that A is 1/2. If there isn't a B, if there isn't a C, they're both 0. So when I find my axis of symmetry, the opposite of B over 2A, well, the opposite of 0 is still just 0. 2 times 1/2 is going to be 1, but 0 over anything is just 0. So that means that my axis of symmetry, right here actually on the y-axis, when I substitute 0 into my equation to find the y, I'll have 1/2 times 0 squared. Well, 0 squared is 0 times anything is still just 0. So my vertex is at 0, 0. It's at the origin. Realize that at this point, you now know your solution. It's 0. That's the only solution that there's going to be. We should still graph this. We should be able to finish up this table. 0, 0 is going to be my center. Negative 2 squared would be 4, and half of that would be 2. If I would use a positive 2, 2 squared is 4, half of that is 2. When I put in a negative 1, negative 1 squared is 1, times a half is a half. And when I put in a positive 1, 1 squared is 1, times a half is 1/2. So when I graph this, negative 2, 2, now notice that this graph is counting by halves because we knew this was going to happen. Negative 1 is at 1/2, 0, 0, 1/2, and 2 and 2. And again, the solution here is just 0 when x is 0. That's what we're going to get for our answer. For this problem, I have an A and a B, but no C. A is 2, B is negative 4. C doesn't really matter when we're just doing our axis of symmetry, but it is 0. So the opposite of negative 4 over 2 times A. 4 over 4, which is 1. That means that my axis of symmetry is going to be right here at 1. Once I know that that's a 1, the y will be 2 times 1 squared, which is 1 squared is 1 times 2 is 2, minus 4 times 2. So this is 2 minus 8, which is negative 6. So my vertex, I did something wrong there. Let me see what I did here. A positive 4 over 4, so 1. Excuse me. When I substitute in, and I'm really sorry that I'm making you sit through the because I put in a different number right there. I bet some of you are looking at that like, Mrs. Kempe, you're being stupid, pick it up. All right, so 1 squared is 1 times 2 is 2. So I have 2 right there, minus 4 gives me negative 2, which will throw in my graph, so I know I'm better there. 1, negative 2 is my vertex. So when I make my table of values, smaller than 1 would be 0 and negative 1, bigger is going to be 2 and 3. When I put in my negative 1, 2 times the negative 1 squared. Negative 1 squared is 1 times 2 is 2 minus 4 times the negative 1. Actually, let's do that. So this was 2. Now that's going to be plus 4 is 6. And again, you can absolutely be using your calculator on this. So negative 1, 6 is right here at the top. We already know that 0, negative 2 is going to be my vertex. So when I put in a 0, I should be getting something in between there, right? And I hope that you can see that if I put a 0 right here, that whole part turns into a 0. This whole part turns into a 0. That's going to be 0. When I put in a positive 2, and again, you should know what these answers are going to be, but when I put in a positive 2, 2 squared is 4 times 2 is 8. 8 minus 8 is also 0, which is what we thought it would be. And when I put in a 3, 3 squared is 9 times 2 is 18. 4 times 3 is 12, so 18 minus 12 is 6. 3, 6. So here's my parabola. The graph that's given here is a little misleading because it looks like it's way off center, but it's still correct. What I need now is where it crosses the x-axis. So that'll be at 0 and 2. Okay, one more quickly. Back to an A, B, and C. So A is 1, B is 6, C is 11. X equals the opposite of B over 2 times A. So x equals negative 3 is going to be my axis of symmetry. When I know that the x is 3, I'm sorry, negative 3, I'll say that y equals negative 3 squared, 6 times the negative 3 plus 11. So negative 3 squared, that's really 9. And 6 times the negative 3 is a negative 18. When I add those two together, that gives me a negative 9. Negative 9 plus 11 would be 2. So negative 3, 2 is my vertex. Negative 3, 2, right there. When I make my table, so negative 3 is in the center, negative 4, negative 5, and then I'll have negative 2 and negative 1. Doing your substitution, again, feel free to use your calculator on this. I'm going to try to save a little bit of time here. Negative 5 squared is 25. 6 times the negative 5 is negative 30, so it's a negative 5 plus 11 is going to be 6. Negative 4 squared is 16. 6 times negative 4 is going to be a negative 24. So that's, excuse me, negative 8 plus 11 is 3. When I put in my negative 2, I'll have 4 minus 12 is negative 8 plus 11 is 3. And then negative 1 squared is 1. 6 times the negative 1 is negative 6, so that's a negative 5. Negative 5 plus 11 is 6. So let's graph that. Negative 5, 6, negative 4, 3. That was my vertex. Negative 2, 3, and negative 1, 6. So here's my parabola. Now remember, the solution is where it crosses the x-axis. This does not touch the x-axis at all. This has no solution. Again, remember, we're looking at what makes the y equal to 0, and it's never equal to 0 on this one. Today, you're going to have a worksheet doing these same kind of problems. You're going to be graphing them, looking for where your graph crosses the x-axis to find the solutions. The answer keys in Schoology, and then make sure that you take the formative in Schoology. And if you need any help with this, let me know.